Thank you for coming. So my presentation is about Kotlin Native, and this presentation is about how things work underneath the hood. And how many people here use Kotlin multi-platform? And okay, great. So my name is Mohit. I'm GD in Android and Kotlin. Uh, so what I'm going to explain to you is how the Kotlin compiler is structured, and specifically how Kotlin Native hooks into it. I'll also talk to you about something it was introduced last year, which is the ability to take Kotlin code and be able to export it to Swift. And now you could use Swift artifacts and pure Swift artifacts, and I'll explain how that works. Lastly, what I'm going to I'm going to do a live walkthrough in code of how things are set up and how do you export things on your own. So before I begin, let me just explain to you. So this is the Kotlin repository, and this is this is the Kotlin source. How many people have worked in Kotlin's repository, explored it? I recommend it. You should also explore Android X for compose code. So this right here is the entry point into Kotlin Native. Whenever you do a command like Kotlin, for example, like Kotlin C, suppose I had a hello world, and I want to compile that, and I want to be able to create a binary to be able to execute Kotlin code like on a Mac, for example, or on iOS. How does that work underneath the hood? And this is the entry point of how things work. You can see that there are entry points to build an Objective-C artifact or Objective-C framework or a C library. And I'm going to explain to you what happens underneath the hood and how these things here work. So the next thing that I'll show you, which is the other part, is Swift. So here's an example. This right here is Kotlin code. Take, for example, that function foo right here. This is right here what the equivalent Swift export of that is. This was something that was introduced last year. It's in beta or alpha. And I'm going to explain to you how that works internally. How do you go in the Kotlin compiler? How does it go from this Kotlin code to this Swift code right here? So that's going to be, so going back to my slides. So suppose that, so I have a YouTube channel where you could check my content out, where I have everything that I'm going to present on. Also present on internals of Compose and how it works underneath the hood. I'll walk you through the code in there if you want to check that out. So suppose, for example, you had a Kotlin multi-platform application and you were sharing some piece of code. And you may have you may be displaying something very simple where you have a greeting you're going to display in iOS. You want to display, for example, you may have use expect actual. This is, I'm sure all of you know this. If you're using KMM, you may have some scaffolding to give to for this is simple interface type of code where you're displaying, you're going to provide some platform string. People build logging, for example, by using expect actual. And you may have, so this is an iOS implementation here. This is in Android, the common. So you have an iOS implementation. And you may have some type of class that hooks into that. So when you go about building this, you could build different things. So you could build a Swift artifact now, but you could also build an Objective-C artifact. And both of them have their ups and downs. Obviously, no one on iOS wants to use CocoaPods, or no one really wants to use Objective-C artifacts. That's one downside from the iOS perspective. So this is what the generated code looks like. If you look into the artifact of that equivalent code right there, of that actual class, and there is some helper that gets added to be able to make it easier to use on the Swift from a Swift standpoint. So this is what, so you can see the helpers right there. It has the Swift annotations, they're there. So now they added the ability to, no one wants to use an Objective-C artifact. Now they added the ability to be able to generate, to be able to export that Kotlin code into Swift. And this is what it looks like underneath the hood. Whenever you generate an artifact, like for this simple code right here, this is the equivalent that this is going to look like if you use Kotlin and Swift export. So this is really a game changer because you get like language features, and this is something, it doesn't support everything in Swift right now, so it's being built out. So I'm going to explain to you how that works. The first thing is, how does the Kotlin compiler work underneath the hood? And this is good to know if you want to know how K2 works, if you want to be able to explore things underneath the hood. Suppose you had some sample Kotlin code like this. What happens underneath the hood is that it gets translated into a tree called a PSI. So KT, Lin, Detect, they all, parse this out to be able to do Lin checking. And here's a very simple example of a PSI tree of that code. So the next step is to be able to do this is to do some semantic analysis. So you may have heard that K2, like K2 was released, you have to do updates. K2 is an API that was built with, one of the motivations was to be able to extend Kotlin, to be able to make it easier to be able to support Kotlin and Swift export, to be able to extend it to Swift. And that's what it does underneath the hood. And semantic analysis, we're looking at your overall code, trying to get meaning out of it. And it gives you some specific result. So what happens in K2, with the K2 in analysis, what happens is that your code gets translated into a set of symbols. This is important to know because underneath the hood, these symbols could also be translated into Swift symbols. And that was one of the motivations, design motivations, to be able to extend the language underneath the hood. So when you look at this, the last step that happens is that there is something called intermediate representation. This step right here, from here, I could convert that and to go to LLVM-IR, or I could convert that and go to Swift-IR from this step right here. Compose compiler plugin mutates this IR right here. It adds, when it sees an annotation at composable, it adds in like composer, like those types of parameters by doing like modifications on this IR right here. This is a snapshot of the compilation process. So this right here is what IR looks like. This is not, the API is not documented, but what you could do is that I could set up visitors to be able to modify my functions and very different things. That's what Compose Compiler plugin does underneath the hood. So this right here is the front end of the compiler, and the back end of the compiler is right here, and K2 right there sits on that semantic analysis side. So this is built in a way where Kotlin native could hook into these different things. There's an API that it is exposed. Kotlin native used to be in a separate repository. It used to be in a separate repository, and it was moved into the Kotlin repo. In order to be able to do this, you need to be able to build a reusable architecture to be able to hook into different parts of the compiler. So when you look at this, so as I told you, the last step is IR, and I could switch from IR to LLVM-IR or Swift-IR. In Kotlin and Swift export that's what happens. So here's an example of, this is a shared module called greeting. And what happens is that the way this gets constructed is that in Kotlin native, when I go and take your code to IR, I have to convert it to LLVM-IR. And from there, I could either create a library, I could create an Objective-C framework from there. I'll show you the LLVM setup there. So when you take a step back in Kotlin native, the way the compiler is set up is that this is like the overall architecture, and there's something called a phase engine. In Kotlin native, whenever you're generating any type of artifact, whether it's a library or targeting some platform, there's a units of work that happen underneath the hood, and it happens in the sequence way. And they're all called phases. And there's a driver underneath, and it's a phase engine. And the reason why this is architected this way, one is that it's easier to understand, gives you a good mental model of things, and it's easy to modify and extend. And and from there, I could generate and do all these things, create a binary, C library, Objective-C framework, klib. So I could also generate Kotlin Swift export. The one thing to understand is that in this process, the K2 API right there is that part right there. And let me show you. There's a reason why people upgraded things. It's good to understand why, and let me show you. So this right here. So this is how, when you look at that method right there called analyze, as you're typing in your code, it gets translated into a set of elements. All those elements get fed into this simple API right here, an analyze API. This analyze API could look at your overall code and give you a result. It could tell you whether you have any errors or not. This right here is generic enough to be extended to add Swift support. And this right here is an example, a Swift example, a Swift equivalent of that, because it was extended. So there is a motivation from a developer point of view why it was designed that way, to be able to extend it to different languages. So let me now go back. So how does the Kotlin native work? So suppose I start with a very simple example, which is this, and I want to be able to run this Kotlin code on a Mac. If you want to target to, for example, a Mac, which is this machine, the artifact you need to generate is a KXE executable. How do you go about from this code and underneath the how does that work? How does it hook into what I just showed you? So suppose I ran this command right here. I had a file and I ran this command, and it would generate this artifact right there, a KXE. In order to do this, I need to be able to generate this code right here. This is bit code. This is bit code that a Mac understands. And how do you go about generating this bit code right here from that piece of small example? How does it happen underneath the hood? So there are these are the steps. First thing I need to do, just as you would do on a JVM, I need to be able to look at your Kotlin code and to be able to do some form of analysis on it. I need to be able to hook into the existing compiler. And I need to be able to then go to the back end of the process and to be able to use LLVM. So how does that work? So this is the architecture. The first thing is that there's a driver that adds in. So what happens is that when that code gets transferred in, it goes through the process of the binary. And there are specific units of work that gets executed in order to generate your artifact. So let me give you an example. So here are the different phases. So these are different units of work, which is, for example, I need to be able to take your code, which is PSI, and to be able to convert it to IR. And there are other types of processes in there too, which is running the backend. This is all the chunk of work. These are called phases that happen whenever you want to target anything like in Kotlin native. This is good to understand because first you could think about how to extend this if you want to be able to extend it to other different target platforms. So, and by the way, how many people are Android developers? Well, that's good. And you're a build engineer. How's it going? I remember. So, when you think about building an Android app, what do you use for architecture? How many people use MVVM? MVI? MVP? Oh, no one is raising their hand. God, thank God. So what I'm trying to explain to you is from a mindset of someone who builds compilers. The one challenge is that how do you go about thinking things even though in this world there's no UI? There's no UI, you're not really building, you're not really setting up a state machine. So there's an equivalent to building something like an architecture in this world, equivalent to like MVVM, MVI. When you look at MVVM, MVI, you're thinking in terms of like, how do I partition my code, right? The view model has your business logic, the view has your UI. And the question in this world is that, how do you go about partitioning logic together? And there are different ways you could take, right? There isn't really, like when you look at client-side Android development, you have like cookie cutter solutions. Like someone will tell you like use like MVVM or MVI or whatever, like, or you could use frameworks like Circuit, or you could use Molecule. I use Molecule like with MVP, reactive architecture. And in this world, there's no cookie cutter solutions. You know, this is like simple OOP, object-oriented programming. And so you have to think creatively. You have to think something like that's going to extend, like scale. So this is a different world of thinking. My second thing that I want to raise is that, so how do you go about understanding how things work at a bottom layer? Because if you read the documentation, it's very much of a surface level understanding. In order to be able to understand even how Compose works, the Kotlin native, how do you go about understanding a very complicated code base like the undercourse repo? And there's a way to a framework to be able to think about things. And my presentation is more of what is that framework? How do you think about this to be able to dive deep into lower level stuff? Now, most people don't, and that's okay. So there are a couple of phases there. And what I want to talk about is that each phase has a name. It has a name, you give it some type of an input, and it produces some type of an artifact. And what I'll show you is how that looks like right here. So this is an example right here of a phase. So when I look at this, when you look at this code, if I go into produce binary, when I try to produce a binary for like a Mac, there are three things that happen. It runs the front end, it runs the PSI, and then it runs the back end. And you could see that it tracks the performance of it. And what you could do is that with the Kotlin native compilers, figure out how long each of these take. Just like in an app where you have to think about performance, there are performance metrics that you could get from here. So the other thing is that when you look at and run in this, so I'm going to go to run front end, and you'll see a lot of code here. The one thing to understand here is that this code right here, the way this is structured, is that this code lives right here in this module. You can see the module is Kotlin native. When you look at the Kotlin compiler, you'll see a lot more modules right here. You'll see right here, this right here, if you look at all the way down there, that's the IR module. All of these other modules, they provide API, like similar to the way you architect an Android app, where you're able to have like a module that has utilities and you're able to like call those methods in there. There is a structure in which how this is arranged, and it has to be arranged in a way where I'm able to hook into here in this phase all those different points. I need to be able to hook into like generating the IR, for example. So let me show you how this works. Okay. So a compiler phase, for example, has all these different things, has a set of conditions, and I could get a result back. And a phase body has an input, and I also could get an output. And here's an example of a front-end phase. In the front-end phase, I want to be able to do analysis and get a result back. And in this phase, when I do that, it hooks into the front end of the compiler and does analysis there. That's where all the code lives. That's where the K2 code lives too. So let me give you an example of the backend phase. Suppose I want to be able to go from IR and to target and create a binary file. The way this works is that, oh, I saw you're taking a picture. Oh, sorry. There you go, taking a picture. Thank you. One challenge about presenting about something like this is that it's very complicated. And it's not even something that an LLM could tell you how things work. Fuck me. So when you look at this, this right here are the steps to do backend. This right here is the code that creates a binary file for you. And the way this works is that what I'm going to share with you is that there are Kotlin bindings to the LLVM IR, and it looks like this. So inside of the Kotlin compiler, so how many people have worked with LLVM? No. Oh, one person, great. So LLVM has bindings for different languages. And it has bindings for Python, for like Go, and also has bindings for Kotlin. And the Kotlin compiler, native compiler, has this. And it's able to learn how to be able to take IR and to be able to convert that over to LLVM IR. And then from there, you could generate a binary file, some artifact. And this is what it looks like. So it has a visitor inside. It uses a visitor pattern. And this right here is Kotlin IR. And I'll show you the LLVM IR. So in Kotlin C, there's a command where it could dump out what the IR of the code looks like. And this is what it looks like. Oh, got another picture. So, so that right there, the Kotlin compiler plugin, for example, like is able to like traverse this and mutate it. And the other thing I want to show you is that, for example, I want to generate some function. I want to generate an LLVM callable, for example. This is the equivalent of an IR function. And it looks like this. Let me give you here. Let me give you an example. This right here is the LLVM IR. It goes from there to there with the LLVM bindings. And from here, I could target this to anything. For example, I could run this on a Mac, for example, when I want. So if I were to, this is what that whole code would look like underneath the hood. And you could print out like what this looks like. So the other part is that, so the next part that I'll show you, if I, for example, want to print out the bit code, that's what it's going to print out from that LLVM IR. The other thing I'll show you is, suppose I want to get the performance metrics. This is how long it took to do each of those steps. Those are each of the steps that happen in Kotlin Native underneath the hood that you could get performance metrics on. And the goal from a compiler standpoint is that how do you improve these metrics so that it doesn't affect you as a user? There's a command that you can run right there. So the last thing that I want to share is Kotlin and Swift export. So how many people have tried out Kotlin Swift export? No? We should try it out. How many people use Kotlin Playground? Oh, did you know in Kotlin Playground you could like try out Kotlin Swift export? Well, you gotta try it out. You know, how come the JetBrains booth didn't tell you? They should demo that. They should demo that, you know. So I'll show you how that works. Okay, so this right here is Swift code right there. In order to generate that code right there, I need to create a model of it which looks like this. I need to be able to take each piece of your Kotlin code and I need to be able to like map it to a Swift construct. What is like, for example, like a function, an import, etc. From a compiler point of view, how do you go about building that? Think about that. Well, this is a different problem like than building an app. It's a much complicated problem. The way you go about doing that is, the way they went about doing that is by being able to extend the K2 API. So when you look at IR, when you look at, for example, let me show you something cool. I was showing Ben this. So let me show you this. So this right here is from the Kotlin Compose Compiler plugin. That right there is simple compose code. When you run that, this is the code that gets generated at the bottom. This is the code that gets generated right there. You can see that there's information that gets added in order for compose to run. So in order to do this, the way it happens underneath the hood is that, I'll show you. This right here is the transformer that gets run right here. Let me show you. This right here is the thing that gets run. What this does is this. This piece of code right here adds in this composer. That class is responsible for mutating that parameter right there. It adds in a composer. And the way it does that is by doing IR manipulations. So when you go into this, you'll see that it's creating right here. It's redefining that function. And that right there, that call IR info is not documented. That comes from the IR API. So when you look at this comes from IR API. You'll see this right here is from an intermediate. IR stands for intermediate representation. This is an example of a specific element. So there is a Swift equivalent of this. They extended this into Swift. So when I write some type of Swift code like this, when you take some Kotlin code, it gets converted into IR. In order to go to that, it has to get converted into Swift, into this model right here. And then there's a translate done. I'll show you where that happens. So here's the code. All right, so right here. So this right here, if you look at this, if you look at right at the over there, you see that there is an SIR module. That was the thing that was introduced for Kotlin Swift export. And in here, there's a standalone tool, meaning that you could hook into yourself to play around with this. And it has an API to be able to convert this to for example, Swift. So you can see that there is this right here. So when you convert things to SIR, this method takes in that module and it basically gives you a string representation of Swift. It goes Kotlin all the way to Swift. That's how it works underneath the hood. This is in beta. It doesn't support all language features. And the last thing I want to share is that how do you go about exploring things on your own? When you look at this right there, the best way to understand how things work underneath the hood is to look at test data. And you could basically look at, for example, there are tests. For example, this is a class. This is Swift code, class with a specific function. And this is doing an assertion. This is the result. So you could look at test code to figure this out. There's all the test data. And I want to stop there. So I hope that was helpful. That's a foray into a world which is different. That's basically how most of the things you see are built underneath the hood. In order to, how many time I got left? I got about, it's 4 o'clock. Got 10 minutes. If you want, I could also do a run through how Compose works underneath the hood on the Indian.x if you want. Could answer any questions in there if you want. Could show you how to work with Compose code source. Show you how a lot of the questions that you never have an answers to, any performance problems. That's it. Anyone got questions? Hope that was helpful. Thank you. Thank you for coming. I'll give you something for free if you want. I'll give you a beer. So over there. Do you want to see Android X compose source? All right. Okay, this is the good stuff. How do you work with compose source? How many of you have worked with compose source? Oh, one person. Okay. So I have the compose source checked out. So there is a GitHub repo. This right here is the Android X repository. Every Android X library, everything that's been presented here. Want to look at the source code? It's all in here. How do you open up Android Studio and explore the source code? There's a script that handles it for you. CD frameworks. Let's go to support. Oh shit. Sorry. CD support. Right there. See that? There's a script in there called Studio W. You'll see right there at the bottom. If you want to be able to open up the source code for any library, this you could add in as an option to that script. So if I want to do Studio W compose, it's going to open up Android Studio for me. It's going to open up Android Studio with the compose source code checked out. So this is fun, exciting stuff. So this is not the compiler plugin. That's in the Kotlin repo. Let's see. Where do we want to start? Let's start with the slot table. There was a presentation this morning by a Googler about how that works, which was surface level. But here's how things work underneath the hood. Whenever you write some source compose code, the first thing that happens is initial composition. And underneath the hood, there's a slot table that gets created. Suppose I want to be able to play around this in the Android X repo. I want to be able to take compose source code to look at what happens. I'm going to write a test. Here's a simple example. Let's start with this. Could anyone tell me something special about this piece of code? Lazy column with 2 items. What happens underneath the hood? Does anybody know what a subcompose layout is? What does a subcompose layout do underneath the hood? What makes this piece of code interesting is that for each item, it creates its own slot table. What does that slot table look like? I'm going to run this piece of code, and I'll show it to you. So, by the way, there's a module called integration tests where you could run it. So, let's see. Oh my God, we got an error. Fuck. Sorry. Let me run this again. We got an error. All right. Well, hold on. Let me run this again. You know why we have an error? Because the Wi-Fi is not good. And that is life. I wish. How do I show you this? Oh man, I wanted to show you. I wanted to show you what the slot table looks like. And when I run this code, it was supposed to print it out. I showed it to Ben. So this right here is the composition class where the slot table gets created. And let me show you. So for example, right here, so this composition class there's an ability to print out, to print out the contents of a slot table. And there's an internal API, so I could do to debug string. Composition internally builds a slot table for me, and right here at the top. So if I were to do, so this is a slot table right here. So if I were to do like this, let me open up a test. So right here, when you build that, underneath the hood, it will create a set of groups for you. So right here, this piece of code right here, this row right here underneath the hood, it creates a layout. A layout underneath the hood emits something called a layout node, which looks like this, which is this right here. This layout node gets created. For a row, column, it has a measure policy. All of that gets stored in the slot table. And unfortunately, I can't show you. Let me try to run it again. Oh my God. Let me. Well, unfortunately, I cannot show you, but you're gonna have to trust me. You can check it out on my YouTube channel. And that was about it. Any other questions? I'm sorry, I couldn't. I was excited, but they didn't want it. And if you're in London, I'm presenting in London. I'll be. Hopefully, it works there. Uh, that's it. Thank you. What a.